G'day guys, Socket here. Today we're going to continue on with our car audio amplifier series, and in today's episode we're going to take a look at transistors. So you'll find transistors all over your circuit board. These things down here are transistors. Here are the power transistors that are used to drive your transformer. Here are the output transistors that are used to drive your speakers. They're an integral part of your car audio circuit board. So let's go and take a look at transistors.
So transistors are used to amplify electrical signals or act as switches or valves in electrical circuits. They're made up of semiconductor material and they're easy to identify because they have three legs or terminals. There are two basic types of transistors, the bipolar junction transistor or the BJT, and the field effect transistor, or more commonly known as a FET. They both do the same thing, they just use different electrical mechanisms to achieve the same outcomes, which might be amplifying a signal or switching on and off, or controlling the amount of voltage that's flowing through a transistor to an electronic component. In our car audio amplifiers, the power section has a set of power transistors, which we often refer to as MOSFETs, which are used to drive the transformer in the amplifier to supply power to the power rails. And the other important set of transistors found in your car audio amplifier is the output transistors. These are the transistors that drive your speakers and add the amperage that the speakers need to move back and forth. So let's have a look at how a transistor works, and we're going to start with the bipolar junction transistor, or the BJT. These were developed back in the early 60s as a replacement for vacuum tubes. They're not as common in modern electronics anymore because they've been replaced by the more advanced FETs, but we're going to have a look at them because they're much simpler to understand. So earlier we looked at diodes, and if you remember, they were made up of two semiconductor materials, right? A type P and a type N. The P type is positive and the N type was negative, and it let electrons sort of flow this way, but it wouldn't let electrons kind of flow in the other direction, right? So a transistor is similar. It's also made out of semiconducting material, except there's a third layer in the middle that controls how much electricity can flow from one side to the other. So just like the diode, it's made up of N-type and P-type semiconductor material. And in this case, this transistor would be called an NPN transistor because it has a negative layer, a positive layer, and another negative layer, right? Or two negative layers and one positive. Okay, so just to confuse things, transistors also come in PNP configuration, right? Where they have, two P layers and one N layer. The main difference between the two is the direction in which the electrons flow. So with the NPN transistor, the electrons move from the highly doped semiconductor to the lightly doped semiconductor because, this has more electrons, this has less electrons, and the electrons want to kind of flow this way. But in a PNP transistor, the electrons want to move the other way, right? So this is highly positive and this is a little bit positive, and the positive semiconducting material will want to attract electrons, so the electrons will flow this way. They both work the same way, the transistors, only the forward and reverse bias on these transistors are flipped. But for our purposes, we're just going to ignore this PNP transistor and just look at how the NPN transistor works. So with that out of the way, a transistor has, as I said before, it has three legs or terminals, and on the BJT they are called the emitter, the base and the collector. So when you connect up the power supply, the electrons flow from the power supply through the emitter to the base to the collector, and then are taken away to the device that the transistor is connected to. That could be a, I don't know, whatever it's connected to, like a transformer or something, right? So the emitter basically emits electrons, and that's why it's called an emitter. The collector collects electrons from the base area, and that's why it's called a collector. And the base acts like a barrier between the two, controlling how many electrons can move from one side to the other. So let's talk about the base and how it controls the flow of electrons. Well, the base acts like a very thin barrier between the emitter and the controller, right? But it's a very special barrier that gets weaker as you apply current. So when there is no power applied to the base, the barrier is very strong, and so it won't allow any electrons to flow through the transistor. But when power is supplied to the base and it exceeds what we call the base threshold voltage, which for silicon is about 0.7 volts, the barrier weakens to a point where the electrons can start to flow across what we call the P or NP or PN junction, right? So the interface between the two semiconductors. So when the power to the base is increased, the barrier becomes weaker. You can continue to increase the power up to the point where the barrier has almost collapsed, and the transistor will allow the full flow of electrons through the transistor, and that is the point at which we call the transistor has been saturated. So a transistor can act like a switch, and it can be either on or it could be off, or it could be kind of part on. And so in this way it's kind of acting like a valve, controlling how much current is allowed to flow through the transistor. But there's also one extra special feature that makes transistors very special, and that is transistors are used to amplify signals, and it does this because a very small signal or input signal to the base, so let's say 1 volt, is usually very small compared to the voltage that is traveling through the transistor. So I can apply a 1 volt input signal here, and I can get somewhere between 10 to 50 volts coming out of the collector. And this is super useful because we can use this to amplify an input signal. So the small input signal from your head unit coming into the base can be amplified or copied and then amplified by a much higher voltage that is needed by the output section of your amplifier to drive your speakers. So that's bipolar junction transistors out of the way. So let's talk about the other type of transistors, these field effect transistors, or FETs. Now, these transistors were developed in the late 60s as a modern, more advanced version of the bipolar junction transistor. But today FETs have all but replaced BJTs in modern electronics. And there is a special kind of FET found in car amplifiers, and that's called a MOSFET. So MOSFETs are metal oxide semiconductor field effect transistors. I mean, yeah, don't try to say that when you're drunk. But they have a layer of metal oxide which is used to generate an electric field, and that's why the name metal oxide semiconductor. And MOSFETs are a more modern version of a FET. They have superior power consumption, voltage control, and all of this type of advanced in almost every way over the FETs that were developed in the late 60s. So let's look at how MOSFETs work. So like a BJT, the MOSFET has 3 terminals, but this time they're called the source, the gate, and the drain. And just like the BJT, a FET or the MOSFET consists of a whole bunch of doped semiconductor material. But instead of using the semiconductor as a barrier, to control electron flow, the MOSFET uses an electric field. But like the BJT, there is alternating sections of negative and positive semiconductor material from the source to the drain. But in addition, there's a zone called the body, which is a little bit like the barrier in the BJT transistor. And there's also a layer of metal oxide that separates and insulates the gate from the source and the drain, which we'll talk about in a minute. So like the BJT, voltage enters in through the source, goes through the transistor, and then it comes out of the drain, right? But in the case of the MOSFET, the conductivity between the source and the drain, this conductivity around the barrier and allowing it to, block or allow electrons through, is controlled by an electric field that forms around the oxide layer when we apply electricity to the gate terminal. So when there is no voltage on the gate terminal, no electric field is produced, and just like in the BJT, no electrons will flow across the transistor. But when a voltage is applied, an electric field is generated which affects the conductivity of the semiconductor material in the body, which allows electrons to flow from the source through the transistor and to the drain. And just like the BJT, a very small input results in a large input coming out of the transistor. And just like the BJT, we can use this type of mechanism to amplify our input signals from our head unit to turn it into a signal that we can use to drive our speakers. So all transistors work on the same basic idea, they just use different mechanisms to achieve it. So there you go, guys. That brings us to the end of today's tutorial on transistors. In the next episode, we're going to take a look at capacitors and how those work. So I hope you found today's tutorial interesting, and as always, I will catch you in the next episode.